Determine the BCD equivalent of, we have been given this binary number, which is base 2 number, and we are supposed to change to BCD equivalent. As we know, BCD itself is a binary number, but whereby the bits are in 4 bits group. So this question can be very tricky in that already we have the binary number in groups of 4. So you cannot copy this number and say it is the BCD. To change BCD to that is to change binary to BCD, you have first to change to decimal. The reason why we change to decimal is because BCD, we normally remember BCD stands for binary coded decimal. So we have to code the decimal number but not the binary number. So we code the decimal number, so that is why we have to change our number into decimal first. So we have this we have the number 1100, we have 1111, we have 1010, and we have 1001. So into decimal we use the power form. So we count the powers from the right. So at this point power will be 0. We have 1, 2, 3, 4, 5. We have 6, 7, 8, 9, 10. We have 11. We have 12, 13, 14, and we have 15. So we shall be taking the particular digit times 2 power, the power indicated at that point. So we shall have 1 times 2 power 15. We add 1 times 2 power 14. We add 0 times 2 power 13. So we are going to add like that up to where we have the power of 0. So we have 0 times 2 power 12. We have 1 times 2 power 11. 1 times 2 power 10. 1 times 2 power 9. We have 1 times 2 power 8. We have 1 times 2 power 7. 1 times, that is 0, times 2 power 6. 1 times 2 power 5. 0 times 2 power 4. Then we have 1 times 2 power 3. 0 times 2 power 2. We have 0 times 2 power 1. And lastly we have 1 times 2 power 0. So we have the next step is written like we write the powers like that. So after that you have to take the equivalent values of all these numbers. Remember where we have 0 multiplying the 2 power whatever power will give us a 0. So when you do all that, you'll get a decimal number which is 5316 base 10. So that is the base 10 number that we get. Now we code this number into BCD form. So we have our number is 5316. We code it into BCD, and coding it to BCD means this is here this is 5361. We get 53161 base 10. So we have 1 here. So when coding, you write every digit of the decimal number into 4 bits. So in this case, 5 in 4 bits is 0, 1, 0, 1. 3 is 0, 0, 1, 1. 1 is 0, 0, 0, 1. 6 is 0, 1, 1, 0. And here we have 0, 0, 0, 1. So after that, you join the number to form the BCD number. So we have 0, 1, 0, 1. We have 00, 1, 000, 1, 0, 1, 0, and we have 0001. And this number now is our BCD number. So as you can see, this number is not equivalent to the binary number that we were given, because we normally code the decimal number into BCD but not the binary number, and that is why we first convert this to get the decimal equivalent. Then after that we change to the BCD.